So I'm super excited to introduce our first speaker today. It's Sir Peter J. Koros. So Sir Peter is a graduate of secondary education, major in physical science, cum laude at Capiz State University main campus. He is one of the 10 outstanding students of Capiz in 2019. He was a former DOST JLSS scholar and is currently taking Master of Chemistry at the University of the Philippines, Visayas. He is also a Project Sparta scholar taking the data science pathway. His research interests are in the fields of nanotechnology, and his thesis focuses on the green synthesis and characterization of silver nanoparticles from alagao leaf extract. During his student internship, he mentored a group of researchers that works on the inhibitory effect of silver nanoparticles against E. coli. And during the pandemic, the research team in Rojas City created a UVC disinfecting chamber and tent that helps sanitize used PPE materials. Right now, he continues to mentor high school students in their research projects, not just in the Philippines, but in other countries as well. So today he'll be talking about data analysis in research, and I'll turn it over to him to start his presentation.
Okay, so did you know that in Netflix they have the so-called artwork personalization, where they tend to show specific artwork of a movie or a series based on the user's watch activity? For example, we have here an artwork for Stranger Things Season 2 for one user, and then we have this another artwork for the same season of Stranger Things for another user. So as you can see, each user have a specific artwork personalization. Here are the other artwork for Stranger Things Season 2. So when you as a user tend to watch more children films in Netflix, these are the artwork that Netflix usually shows you. If you as a user tend to watch more horror films, here are the artworks that a Netflix usually shows you. And if you are fond of watching romance or love story, here's the artwork that Netflix will probably show you. Now, you might be wondering what Netflix has to do with my presentation. Well, I tell that story because it illustrates how data analysis and data analytics govern our daily lives. From the simplest to the most complex, we may not be able to notice them at work, but I tell you, they are pretty much everywhere. From weather forecasting to Netflix and chill, and data analytics or data analysis is more than meets our eyes. So good evening, everyone. I am your Kuya Peter, and just like you, I have been a student researcher struggling with my research paper before. So this was me during the National Science Technology Fair 2013 at Tagaytay International Convention Center, where I presented my research paper in high school. And this is where I met your Ate Florence, who invited me to speak with you tonight. And again, just like most of you here, I sort of struggling to deal with my data. That brings us to the question, how do we deal with our data? Well, let's begin our journey by learning the basics of data analysis. So data analysis is the process of systematically applying statistical and or logical techniques to describe and illustrate, condense, and recap and evaluate data. So in simple terms, data analysis is nothing but analyzing our past or future and making decisions based on it. So we have here the 5 key stages of data analysis. We have defining the question, collecting the data, cleaning the data, analyzing the data, and interpreting the data. The first step in a data analysis process is determining why you need data analysis in the first place. So this is where you ask the right questions or you identify the problem. So this is very crucial part of data analysis process because this will lead you in your data analysis journey. So the very first question that you need to ask in data analysis process is, what problem do you want to solve? So in research, we usually find this in your statement of the problem, where we learn that your statement of the problem should be SMART. And I guess everyone is familiar with this. SMART stands for specific, measurable, achievable, relevant, and time bound. So again, this is a very familiar concept of your statement of the problem, but usually this is sometimes the students get confused in doing or in making their statement of the problem because of this. So for example, let's have a specific example for this one. You're tasked to conduct a research study. So your teacher asks you to identify problems in your community. Now, one day, you read some reports stating that the wastewater in your community has a very high concentration of cadmium. Now, your problem here, or your identified problem, is the high concentration of cadmium on wastewater. Now, your objective to solve this problem is to lower or remove the concentration of cadmium on wastewater. The thing is, you don't know how to do this. You don't know any materials that could eliminate, lower, or remove the concentration of cadmium on wastewater. So what will you do? You do further readings. You do readings on specific related literature that could help you lower or remove the concentration of cadmium on wastewater. And this, you come along with this specific material. This is what we call the magnetic biochar. And then you were intrigued with the property of the magnetic biochar and how it could potentially lower or remove the concentration of cadmium on wastewater. Now you revised your objective and made it more specific. So your revised objective now is to lower or remove the concentration of cadmium on wastewater using magnetic biochar. Now, in order for you to have a strong research problem statement following the SMART acronym, you post this research question. What is the effect of magnetic biochar on the concentration of cadmium on wastewater? So given your research question now follows the SMART acronym, it is very specific. You're able to identify two variables. It is measurable in a sense that you can quantify the concentration of the cadmium on wastewater. It is achievable in a sense that it can be done. Also, it is relevant because, again, you are proposing specific solution to a specific problem. And it is time-bound because you can conduct this in a specific time frame. But in order for us to proceed with the next step of data analysis process, we first need to identify your independent and dependent variables. And I assume everyone knows what independent and dependent variables are. But again, to emphasize, in simplest term, independent variable is the cause and your dependent variable is the effect. So your dependent variable is the one being measured. Now, let's go back to our research question. What is the effect of magnetic biochar on the concentration of cadmium on wastewater? Now, let's identify our independent variable and dependent variable here. Now, what do you think will be the cause and what will be the effect? So basically, it is easy to identify our variables in our research question if it follows the SMART acronym or the SMART principle. Now, let's highlight magnetic biochar because magnetic biochar here is your independent variable. This will be the cause and the effect will be the concentration of cadmium on wastewater. This will be your dependent variable because the concentration of cadmium on wastewater will depend if you apply the magnetic biochar on that water. So you assume, so in this part, you assume na that your magnetic biochar has an effect on the concentration of cadmium on wastewater. With the identification of your independent variable and dependent variable, we can now proceed with the second step of data analysis process, which is the collection of data. So after the problem has been defined, it's time to begin collecting the data needed for analysis. This step is important because the nature of the collected data sources determines how in-depth the analysis is. So um, the question that you need to answer in this step is, how will you gather your data? Data collection, again, is defined as the procedure of collecting, measuring, and analyzing accurate insights for research using standard validated techniques. So this data gathering procedures or the collection of data can be found in your chapter 3 methodology experimental setup, specifically the data gathering procedures. So a researcher can evaluate their hypothesis on the basis of collected data. So in most cases, the collection is the primary and most important step for research, irrespective of the field of research. So regardless of what field you are doing research, the most important and the primary step for data analysis is the collection of your data. So the approach of data collection is different for different fields of study depending on the required information. We have this different instrument in data gathering procedures. We have survey questionnaires, you can do interview, you can do experimental test, as long as it follows standard validated techniques. Now let's go back to our research question again. What is the effect of magnetic biochar on the concentration of cadmium on wastewater? Again, we need to emphasize here our dependent variable. Why? Because our dependent variable is the one that is being measured. Therefore, we need to focus our collection of data on this type of variable. So in our example, the concentration of cadmium on wastewater can be quantified using water analysis or heavy metal analysis. So given with this that you were able to identify your instrument or the process on how you will collect or gather your data, you can now set up your research design. So with this type of research question, we can do pre-test and post-test analysis on the wastewater in order for us to determine whether our magnetic biochar has an effect on the concentration of the cadmium. Now, the third step of the data analysis process is data cleaning. Now, whatever data is collected, it may not be useful or relevant to your aim of analysis. Excuse me. Hence, it should be clean. So regardless of what instruments you use, survey questionnaires, instruments, or experimental tests, we need to do data cleaning. So the data which is collected may contain duplicate records, white spaces, or errors. For example, if you use survey questionnaires, there are certain questions that doesn't have any answers. Maybe the respondents were able to forget answering that specific type of questions. So in data analysis process, the data should be clean and error-free. This phase or this process must be done before data analysis, because based on data cleaning, your output of analysis will be closer to your expected outcome. This is a vital step because ultimately the accuracy of your analysis will depend on the quality of your data. One of the most crucial part of data analysis process is data cleaning, because this in this part of or in this step of data analysis process, you try to organize your data and you try to clean, you try to look for potential outliers that could have a significant effect on your result. Okay, first goal in data cleaning task is removing major errors, duplicates, and outliers. Again, these errors, duplicates, and outliers may potentially affect the result of your data analysis. And then we have removing unwanted data points. So for example, on my field of research in nanotechnology, we focuses on specific wavelengths of our nanoparticles. Therefore, we have to specify specific data range in determining our or in looking for our data. So if you forgot to specify, for example, in an instrument, you're able to forgot to identify or specify the data range. Then in the process of cleaning data, you may remove those unwanted data points. Next, bringing structure to your data. So in this step as well, you organize your data. You put specific data on rows, then others on columns. And then lastly, you fill in major gaps. Again, for example, if you have survey questionnaires, there are certain items that doesn't have any answers. Then it's up to you if you have to fill on that. But in order to remove biases, you need to remove na lang that one. But did you know that 70% to 90% of your time in data analysis process actually happens in data cleaning? This is where you will spend most of your time in data analysis process, because especially if you tend to check for outliers. This is the main focus of step 3 here: removing major errors, duplicates, and identifying potential outliers. Personally, I use RStudio, Excel, and SPSS in looking for potential outliers. But I've noticed that in some papers or in some research paper that I've read, there are certain papers that do not actually go or do not proceed with this step in data analysis process. They forgot to do outlier testing. Which is very crucial actually in the part of data analysis process, because again, it could potentially affect your result. So sometimes I use this principal components analysis in 2D and 3D to identify my potential outliers. So as you can see, there are certain data points outside the ellipsoids, and we call that potential outliers, because as of now, we cannot certainly identify whether those data points could significantly affect our result. There is Later, I will present a specific statistical tool that would validate whether that data points could actually affect your result. Other statistical techniques that I use are normal QQ plot and Baxter Whisker plots in order for me to determine my potential outliers. For example, for a normal QQ plot, there is as you can see, there's a diagonal line wherein most of the data points are concentrated on that diagonal line. Those data points outside that diagonal lines are your potential outliers. So for a formal statistical methods, it has also been developed, or there is this certain statistical tool that can assist in determining outliers, and that is the Grubbs test. So Grubbs test is one of the most popular ways to define outliers, and it is quite easy to understand. This method is also called the ESD method, or the extreme standardized deviation method, wherein this test could validate whether your data points are actually potential or are actually outliers. So now you have a wealth of data. You've spent time cleaning it. Now your data are organized already. Now we are ready for the fun stuff. Remember, raw data alone cannot answer your research question. You need to analyze this raw data to come up with insights. And this is where data analysis, or analyzing the data, comes in. So in this step, you'll begin to slice and dice your data to extract meaningful insights. So using the techniques and methods of data analysis, you look for hidden patterns and relationship. Again, your keywords here are patterns and relationship. And with that, you need to identify or find insights and predictions from that patterns and relationship. Now we have two types of analysis in analyzing the data. We have your quantitative and qualitative analysis. For quantitative, you need to decide which calculations and statistical tests to use for analysis. And for qualitative analysis, you need to consider what approach you need to use to take for categorizing and interpreting the data. So here are certain examples of quantitative and qualitative analysis. For quantitative, we have descriptive statistics. So I think this is very common. So descriptive statistics are used to describe or summarize, again, describe or summarize the characteristics of a sample or data set, such as your mean, standard deviation, or frequency. So these are the common measures of your descriptive statistics. You have your measures of frequency, measures of central tendency, measure of dispersion or variation, and then measures of position. And then we have inferential statistics. So in inferential statistics, it helps us understand the collective properties of the elements of a data sample. So we use these measurements from the sample of subjects in the experiment to compare the treatment groups and make generalizations about the larger population of subjects. So in this type of statistics, you compare specific groups, or you compare means or variance to other groups. So your example here are comparison of means like t-test, comparison of variance, ANOVA, correlation and regression, which is example linear regression. And for your qualitative analysis, I will just show different definitions of this qualitative analysis, because I think I assume that most of you here are in the quantitative type of research analysis or data research analysis. Now, sorry, let's go back to our research question earlier. What is the effect of magnetic biochar on the concentration of cadmium on wastewater? So given with this type of your research question, we can use quantitative type of data analysis. So for descriptive statistics, we can use mean and percentage. And for your inferential statistics, we can use t-test, ANOVA, Spearman, and correlation. Now, in data analyzation, or in this step, you actually find insights from your data. Hindi ka lang nagtatapos sa calculations. You do not end up there. You also need to find insights from your data. So for example, we have collected our data already, we calculated, and then we have these insights given with our research question. Let's say your magnetic biochar could actually lowers the concentration of cadmium on wastewater. And you've also find out that increasing the amount of magnetic biochar lowers the concentration of cadmium. Now, after analyzing your data, it is finally time for you to interpret your result. It is the final step in data analysis process. So data interpretation. So data interpretation refers to the process of using diverse analytical methods to review data and arrive at relevant conclusions. So in the interpretation of data, it helps the researchers to categorize, manipulate, and summarize the information in order to answer critical questions. So in this step of data analysis, you answer this type of question. How does your data solve the problem? And then what does your data implies? Let's have an example. Usually in data interpretation, I've noticed that there are researchers who just describe their data. They just tell you what data are presented on the table or the graphs. But always remember, that's why I put this on my title of my presentation. Data analysis in research more than meets the eye. So you need to look behind the data on why did that happen, or why is your data like that. So you need to back up your data with certain explanations. So for example, I have this graph. This was generated using R. So as you can see, that A, B, C, D, E, F, G, H, I, J, those are certain physicochemical properties of wine from magnesium, like total phenols and flavonoids. So let's proceed with this data. Let's look into this one. So in data interpretation, you usually focuses on your highest data, those data that could actually help you. So for example, this one, as we can see, it has a correlation Pearson of 0.86. So this is an example of a correlation matrix with Pearson R. You have your linear regression here and your histogram. So as you can see, your E and F is very related to each other with a very high correlation of 0.86. So your E and F, these are your total phenols and flavonoids. So other researchers could interpret this as total phenols and flavonoids are directly proportional. So when total phenols increases, flavonoids increases. Well, this is a good data interpretation, but it is not strong enough for your research, because I know I can see it in the graph already that they are directly proportional. But why is that? So sometimes we need to support our claims. So a very high positive correlation can be seen in the scatter plots of total phenols and flavonoid with a person R squared of 0.86. This is because flavonoids are the largest group of naturally occurring phenol compounds, which occurs in different plant parts, both in free state and as glycosides. So there you are. This is a very strong data interpretation as supported by a certain related literature. So again, you go behind, you explain something that we cannot see on that graph. Why is that data like that? So let's have another example. So last example for data interpretation, we have this. On your y-axis, you have enzyme activity, and then in your x-axis, you have your temperature in degrees Celsius. Now, as you can see, as the enzyme activity increases, the temperature increases as well, or vice versa. As the temperature increases, your enzyme activity increases. But there is a certain temperature where the enzyme activity lowers again. So you could say that the optimal temperature to have a maximum enzyme activity is 39 degrees Celsius. But again, we can see this on the graph already. So how do we revise this one? We explain why this happens. So as temperature increases, so do the rate of enzyme reactions. So this increases only up to a certain point, which is, let's say, 39 degrees Celsius, until the elevated temperature breaks the structure of the enzyme. Once the enzyme is denaturated, it cannot be repaired. Again, in your biochemistry, we have learned about protein denaturation, and we know that certain temperature could denaturate your protein. So this is how you interpret your data. Protein denaturation, we cannot see that on the graph. But if you go further into explaining why your data looks like that, then it is a very strong interpretation already. Again, um, to recap, we have these 5 key stages of your data analysis process. You have defining the question, collecting the data, cleaning the data, analyzing the data, and interpreting the data. Now, this time, let's proceed on how to choose appropriate statistical techniques for data analysis. So in choosing the appropriate statistical techniques, your collected data and research design of your study has to fit appropriate analysis. So you need to answer these 4 basic questions in order for you to choose what specific statistical technique is appropriate in your research. First, what type of research question did the study formulate or ask? Next, what type and number of variables does the study want to analyze? And then what nature and characteristics of variable does the study have? And lastly, is your data suited for parametric or non-parametric tests? So first, what type of research question did the study formulate or ask? Earlier, you were able to learn how to specify or make your research problem clear and aligned with the SMART principle. So this time, we have these 3 types of research question. You have your descriptive research question, you have your correlational or predictive research question, and you have your group differences research question. Sometimes these 3 types of research questions can be found on one research paper already. So in the list of your statement of the problems, you could actually see these 3 types of research question. First, your descriptive research question. So in this type of research question, you describe the group of subjects or data and their characteristics in a relatively simple way. So this is a very easy type of your, or a very simple type of your research question. For example, what is the optimal temperature in the synthesis of magnetic biochar? So in this type of research question, you actually ask for a specific answer that could, sometimes we could consider this a very objective type of research question. You actually look for specific answer because this type of research question again is relatively simple. You just describe. Another example, what is the average household monthly income of DOST scholars in Capiz State University? So you look for specific answer. So in order for you to answer this type of research question, we usually use descriptive analysis. We have frequency, distribution, central tendency, standard scores, and percentiles as an example. Next, we have your correlational or predictive, or sometimes you call this the cause and effect research question. So this type of research question involves measuring two variables and assessing the relationship between them. So your keyword here is relationship of your variable. So in this type of research question, you assume that your two variables have a certain relationship. So for example, what is the effect of magnetic biochar on the concentration of cadmium in wastewater? So the example research question posed earlier is a correlational or predictive research question. Another example, is there a relationship in the amount of fertilizer on the growth of petri plant? So this type of research question, you focuses on the relationship of your variables. And in order for you to find specific answers on this research question, we usually use correlational or predictive analysis. We use correlation and regression as your statistical tool. Next, we have the group differences research question. Now, this type of research question actually is very common in most of the experimental type of research. So in this type of research question, you compare groups to one another to find out if there are statistically significant differences between them and one or more outcomes. I think most of you are familiar with this type of research question because it always starts in this phrase. Is there a significant difference on the concentration of cadmium before and after the application of magnetic biochar? So again, this is an example of your group differences. Another example is this one. This is another way of stating the relationship or another way of comparing groups to one another. Is just that in this type of research question, you have a direction. So yeah, it states that it should be higher before and after. Now, in order for us to answer this type of research question, we use differences between groups analysis like t-test, one-way ANOVA, factorial ANOVA, MANOVA, and etc. Next question that we need to answer is the type and number of variables. I think earlier we were able to discuss with your independent and dependent variable, but again, we need to reiterate that you need to really highlight your independent and dependent variable in your research question or in your study. And also you need to identify the number of variable in your research question. There are certain research questions that could have two or more variables. And also you need to clearly define each variable because again, your variable is one of the very crucial parameters in your research. It actually helps you in your this data analysis process. And next, again, you need to find out if each variable have a normal range or different levels. Next, what nature and characteristics of variable does the study have? Again, most of the students or research enthusiasts are actually very confused in this part of their variable. They sometimes forgot to identify the nature or characteristics of their variables or data. Again, to remember or to emphasize that these are certain characteristics of your variable or your data. You have your nominal or categorical measurement, your ordinal measurement, and your interval or ratio measurement. So this is very important for you to identify the nature or characteristics of your variables or data because this will help you as well to identify what specific statistical tools are you going to use in your research study. So if your data are, or if your variables are in nominal or categorical, for example, gender, you need to ask, are the groups equal or balanced? And then are the categories empty or are they filled correctly? Next, if your data or if your variables are interval or ratio, you need to ask, are they normally distributed? Or what is the appropriate range of scores? So this type of variables or data are actually most prone for outliers. That is why this type of variables we usually use in outlier testing. And lastly, we need to address the need for parametric and non-parametric tests. So your parametric test is that the information about the population is known. And in non-parametric test, no assumption about the population is known. This is a very crucial part of data analysis because this is where we start to test our hypothesis. And we need to remember that parametric tests are generally more powerful than non-parametric tests. So there are certain assumptions that we need to meet in order for us to use the parametric test or non-parametric test. The most important assumption is the assumption of normality, in which your data in each comparison group should show a normal or Gaussian distribution. For example, this one, your data should be normally distributed. If it is positively skewed or negatively skewed, then you may opt to use non-parametric test. Here are the other assumptions for your parametric test. But in this presentation, we will focus on the assumption of normality. So what will you do? Let's say if your data does not meet the assumptions of your parametric test. So let's say that your data is not normally distributed. The first thing that you need to do is to still retain and use parametric tests regardless if your data is not normally distributed. Why? Because there are some approaches such as advanced type of ANOVA that are robust enough to overcome minor violations of parametric assumptions, especially if you have a very large sample size. This could justify your reasoning that you can use parametric tests regardless if you meet the first assumption, which is the assumption of normality. The second thing is, for example, if you have a relatively low sample size and it does not follow a normal distribution, then you need to transform the data. You need to undergo or you need to normalize your data. It should undergo normalization because normalization is a good technique to use when you do not know the distribution of your data or when you know the distribution is not Gaussian or symmetrically distributed. So an example of this one is the lag transformation. But what if regardless of very low sample size, it was not able to follow still the normal distribution, even though you already normalized that, then the last thing that you need to do is adopt non-parametric alternative. So proceed ka na sa non-parametric test. So here are the parametric and non-parametric alternatives. So for comparing mean, it is highlighted in blue. For comparing variance, it is highlighted in orange. And for correlation and regression, it was highlighted in yellow. So these are the alternatives if your data was not able to meet the parametric assumption. So if we still have time, I could actually still explain each of this to you rather, but since we don't have enough time already, I would like to thank everyone rather for listening, and I hope you're able to learn something in my presentation. If you need to ask some follow-up questions, then you can contact me in this following contact information. So thank you very much, everyone.